Hello. I'm kind of scummy today because, yeah, been running around and doing some yard work and still need to do yard work. So rain is wonderful, but yeah, constantly needing to weed whack and deal with flowers and yeah, so kind of scummy because I'm going to go outside and do some yard work. But all right, transformation review. Okay, first of all, you should know the shape of all of these things. So an absolute value is a V. Okay, if it's reflected, you know it's going to be something like that. Square root is gonna, I always thought it looked like a turtley thing, just kind of a slow thing. If it's reflected here. Now that's if it's on the outside, okay? Here, if there's a negative on the inside, it's gonna reflect it this way. This one, you're not gonna be able to tell because it's just gonna go back and forth. This one, if there's a negative on the X, it is gonna reflect differently, right? It's gonna reflect over here. It's gonna look different. Okay, parabola, normal or quadratic looks like that if it's reflected on the outside here. Now, if there's a negative in here, again, it's going to reflect over the y-axis. You're not going to be able to see it. This is a weird one. This is a line, and sometimes we don't think of transformations on lines, but I want to show you that it works, and it's cool. All right, so let's start here. You should know that whatever your shift is, so whatever causes 0, -1, whatever it is, exactly as it is, that's your shift. Okay. You should also know that, so this part is your shift. This is going to reflect it. Okay. And 4 normally would kind of make it skinnier or make it go towards the y-axis. So it's going to be reflected kind of skinny. Now, to get some more accurate points, I would just, so you know this guy, I would sub in values, right? I would just make an input-output chart. And, you know, it shouldn't take you too long. These things are symmetric. All right, so sub in 0, what do you get? That would be 1, -4, that's at a -6. Okay, so 1, 2, 3, 4, 5, -6. And do you see how you could come over here and reflect it? It's also going to be at a -6 because these things are symmetric. And then you would just do this and just do this. And again, I would pick friendly numbers. I wouldn't sub in 1/2 and 1.5 and stuff like that. I would just sub in 0, maybe 1, maybe -2 and get it. All right. Let's go to this one. Do you notice that this is exactly the same transformation? It's just the function that has changed. All right, so let's do what we're going to do here. Hopefully I have enough tick marks. Okay, -1, -2. So I'm going to go back and down. And I do know it's not reflected in here. It's reflected here. So normally I would expect it to go here, but the output is getting reflected, meaning it's going to be down here. That should not surprise me. Again, I'm going to make an input-output chart just to help me out. Sub in friendly numbers. So you could be like, well, -1's friendly. Yeah, but we already know that one, right? If you sub in -1, you do get the -2. Okay, that's your starting point. So, I mean, we can do it, but 0 is friendly because the square root of 1 is nice. So that would be what? -4, that's a -6. And notice, isn't that crazy? We still get that -6, -1, -2, -3, -4, -5. -6. Okay, so that's maybe sub in I don't want to sub +1, it's not friendly. I'm going to sub in 3 because you see how 3 gives me the square root of 4. So when I sub in 3, I get 4, square root is 2, -8, that's what, -10. So at 3, 1, 2, 3, I'm at a -10. So that's what, 6, 7, 8, 9, 10, I don't know. But it's going to come, you know, like that, okay? All right. Let's do this guy. Again, should not shock you. The shift is whatever causes 0, -1, -2. So see how they all, as far as like the shift goes, it's all the same. Again, you know this is going to make it steeper, right? Skinnier or, you know, kind of, I don't know how to say it. Like this is taller in a way. All right. So again, if you're like, well, I don't know, I'm good with that first point, Julie, but I don't know after that. Well, maybe finding the y-intercept is a good idea. So let's sub in 0 for x, and let's just see what happens. 0 would be what? 1. 1 squared is -4. Oh my gosh, do you see how that never changes? Isn't that crazy? 1, 2, 5, -6. Okay. And I know this is a parabola, so it's kind of like this. This is nice and V and pointy, but it's similar in the fact that it's symmetric, right? So this is going to go here. Now, again, the difference is this one is a parabola, so don't make it V-ish. It should be very curvy, okay? And again, I could sub in, I don't want to sub in 1/2 or anything like that. So if I wanted to, I could sub in 1, see where it's going, -3, maybe see. But again, I only had to do this point to reflect it over. All right, let's look at this guy. Now, I know this is weird. This is aligned, okay? So this is linear. Let's do what we've been doing, and this I know is going to seem very strange to you because your teachers never show you this, but it's the coolest thing. I don't know, maybe not since sliced bread, but you know, it's pretty darn cool from a math perspective. So, all right, so the transformations even work on lines, which is crazy, but notice it has to be in factored form here, okay? So if it's in factored form, you can see it. If it's not, it kind of gets lost in the simplification, but let's look at this. Notice the shift is still -1, -2, okay? Just like everything else. Now, again, this is kind of that stretch thing. And it's in a line, it's definitely your slope. So I could go rise 4, 1, 2, 3, 4, run backwards. Or I could go what? Down 4, 1, 2, 3, 4, and over. All right, I'm going to draw my line. This is a linear function. And oh my gosh, do you see how it still goes through -6? Isn't that the coolest thing? All right, and you're like, oh my gosh, like that still works. Now, if you're like, but it's not in y = mx + b form, I know it's not. Okay, so to see the shift that's similar to everything I did with the +1 and the -2 and the -4, I had to write it this way. Now, notice if I do the distributive property, I get -4x and a -4 minus 2 is a -4x minus 6. That's how you're used to seeing this line, but notice, what's your y-intercept? -6. What's your slope? -4. Rise 4, go over 1. Rise 4, go backwards 1. And do you see how you have a negative slope there? So when it's in this form, even on a line, it transforms the same way, which is uber crazy. Okay. Now, just a few other reminders. If it's in the inside, so if I have like y = -x², that's gonna, that parabola, this parabola and this, because when you simplify, it's the same, because remember that's an even function. So yes, it's gonna, the input is gonna reflect, but notice if the x's go from the positive side to the negative side, it looks exactly the same, right? Because this thing is gonna be symmetrical. So that line, that point, you know, just gonna reflect there. So you're not gonna see it. If it's an odd power, you would. So like, or an odd function here, because this guy, remember, this is kind of our disco guy. And if you're like, Julie, I can't remember all this, 0 cube, input and output is your best friend. 0, input 1, you get 1, input a -1, you get a -1. And this is kind of that disco-y bend, okay? All right, so notice though here, if I put a negative in here, remember when we did even and odd, a negative times negative times negative, this actually changes the function. It's negative. So the output, so here, if you reflect, you know, opposite the input, do you see how the input, the x's would change, right? So when I reflect this transformation, this guy is going to go, which when we talk about polynomials and behavior and stuff, that kind of all ties together. All right. Hopefully that's a quick review on transformation, helps you. I think the line thing is the coolest thing ever. I kind of just figured it out on my own. I just kind of discovered it, I guess, when I was like, well, do these work on lines? Because no one ever shows you on lines, right? We just don't do that. And it does work in lines, but it does have to be in that factored form to see it. So, all right, have a great Friday. Have a great weekend. Sorry, I'm so scummy looking, but hopefully this works. And then email me anything about quizzes and I will get those to you.